Okay, so this question reads, the Little Mermaid was getting ready for a date with Prince Eric. She was supposed to meet him at 3:05 p.m. When she looked up at the sun from her room under the water, she saw it was about 3 p.m. position in the sky. So if we think about how the sun moves across the sky, it's at the 3 p.m. position. Was she already late for her date, or did she have plenty of time? And this is a multiple choice question, but we still want to make sure we understand the reasons. First, yep, she's already late. The sun appears at 3, but it's really much later. She has plenty of time. The sun appears at 3, but it's really earlier. Or she just has 5 minutes. She's not late, but she better swim really, really fast. So the sun appears at 3, and it is 3. So we want to justify our answer. All right, so which one is it? Well, let's draw our picture and see what poor Ariel has to be thinking about. Okay, so here she is, and there is her fin. I don't know, I'm not a very good mermaid drawer. And here is the sun. Now, the sun's going to be somewhere in the sky, and if we think about the sun moving across the sky like this, where she sees the sun is in the 3 o'clock position. So if this is noon, we'll just say the sun, this is where she sees the sun. And I'm gonna put it in quotation marks. Remember, where we view things across a medium isn't always where it actually is. So I think we can safely eliminate option number C. Okay, so we want to think about where the light is coming from. Ariel's the one viewing the image. She's the one interpreting the location of something. And so the light is coming from the sky. All right, coming from the sky to Ariel. Now she sees it at the 3 o'clock position. That means that whatever ray of light is hitting her eye is in line with where the image would be if in fact the sun was at the 3 o'clock position and there was no medium change. So I've drawn the ray that represents the 3 o'clock position in her visual system. It would hit her visual system at a location that is represented of the world of sort of that 3 o'clock position. Remember, our retina is a map. So if the sun was truly at the 3 o'clock position, that straight line from that location in space to her eye, the path within the water would be along this line. Okay. So does the sun's light actually travel that path? Well, no, of course not. Because if this ray of light that was in line with the 3 o'clock line hit a boundary, it would refract. It would refract. So how does light refract? How do I get a light ray that is at this angle of refraction? So let's think about that normal for a moment and how light goes from one medium to another. This is air. And this is water. And we know that the N of water is greater than our N of air. Our index of refraction of water is greater than the index of refraction of air. And when we're going from air to water, we bend towards the normal. So from air to water is towards. So in order for this light ray to be coming from something that started out in the air, it had gotten bent towards the normal. And so the angle of refraction has to be smaller than my angle of incidence. And it had to have come from a ray that had a larger angle of incidence than it did angle of refraction. That was shallower relative to the horizon. And so the sun truly must be in this location, so that the ray of light comes in and refracts towards the normal and hits her eye. So the sun is lower in the horizon. Ariel is late. All right, so A. She's already late. The sun appears at 3, but it actually has to be lower in the horizon for the refracted ray to be located in such a way that it hits the retina so that it appears at that 3 o'clock position. All right, good job.